Alright, in this video I'm going to introduce you to how to solve rational equations. So let's start with a little bit of review. First of all, let's look at how we multiply fractions. You may recall we just multiply straight across. So here 3 times 8 is 24, 4 times 9 is 36. And then once we've done that, notice the 24 and the 36 have common factors. We can divide, the greatest common factor for those two would be 12. So dividing by 12 we get 2 in the numerator and 3 in the denominator. And so our final answer is 2/3. Now, we could have done this a different way, some of you may be saying. We could actually do some canceling up front. Think about what we just did. We multiplied to get the 24 over 36, and then we did division by 12 to get back to the 2/3. It seems like we're doing extra work here, and in fact we are. So if you actually look at, do this again. Look at the original problem. We have a 3 in the numerator and a 9 in the denominator. We could actually divide out a factor of 3 right up front. So let's go ahead and do that. Divide by 3, you get 1 in the numerator and 3 in the denominator. Notice also the 4 and the 8 are divisible by 4. So let's divide each of those by 4. And then when we multiply across, we get the 2/3. So this is a little bit easier. Let's go ahead and do a couple of examples this way. Actually, on number 2, we still, if we want, we can multiply straight across. Now before we do that though, let's go ahead and write that 12 as a 12 over 1, because remember we want to multiply our numerators and multiply our denominators. Our denominator on the 12 is a 1. So we end up with 12x over 4, which is 3x. But again, we're going to be using the approach that I used on number 1 on the second solution there. So we would actually solve this way. We notice the 12 and the 4 are both divisible by 4. So we'll divide each of those by 4, and we get 3 in the numerator times x. And so that's how we get the 3x. Let's look at one more example. So if we have 12 times 3 halves x, notice this time the 12 and the 2 will cancel. We'll be left with 6 times 3 times x, and we get 18x. All right, now I want to look at how we solve equations, what we've talked about before. So here I've got 2 equations, and in fact there's 2 ways we can solve these. I'm going to start with building on what we did previously. Look at number 1. Our goal is to get x by itself, and so we got to get rid of the 12. So it's x divided by 12. So if we do the opposite of dividing by 12, which would be multiplying by 12, actually let me do that, we're going to get x is equal to 48. So that's a one-step equation because we had to multiply by 12 on each side, and in one step we were able to solve the equation. Notice on number 2, we're going to need to multiply both sides by 3 to get rid of that 3 there, and add 4 to both sides to get rid of the 4. And so notice that'll be 2 steps. So this is a 2-step equation, and we know we always add or subtract first with 2-step equations. So here I would add 4 to both sides, and then I have division by 3, so I'll need to multiply each side by 3, and we're going to get x is equal to 27. So the technique we used previously works fine here, but as we get into more challenging equations that have fractions in them, there's another technique that tends to work a lot better. It's a lot more sophisticated. We call it clearing fractions. In fact, you may recall the technique I showed you in my previous videos, the CSI 1 and 2 step. We never did clear fractions, and so that's what we'll be doing now. So first of all, To clear fractions, we multiply each side of the equation by the LCD. So the cool thing about clearing fractions is basically if you multiply both sides of the equation by the LCD, it turns out the fractions will go away. And I know for some of you that's a good thing. So in one step we can clear the fractions away. But this is a key step. So let's go ahead and do these problems using this approach. You'll see on number 1 it really isn't any different, at least the way it looks. So I'm not thinking so much how do I get x by itself here. I'm thinking, hey, I need to clear the fractions, and I do that by multiplying by the LCD. So here I only have one denominator. That's going to be my least common denominator, or LCD, and it's 12. So we'll multiply each side by 12, and we get 48. So you'll notice our solutions look exactly the same, but the way we were thinking about how to solve each of these was different. The goal here, using this approach, is we're trying to get rid of the fractions. Trying to clear the fractions, that's our first step. All right, so let's look at number 2. And so my LCD here is 3. I only have one denominator. And so now notice here, basically, I need to multiply each side by 3. Now I got to multiply the whole side by 3, so if you look on the left, notice I actually have to distribute. Now this isn't the way we're going to do these. Actually, you know what, let me do something real quick here. The thing to keep in mind here is when we multiply each side by 3 here, both terms on the left have to be multiplied by 3. So we won't normally write out these problems the way that I did here in green. We'll actually do it a little differently. Basically, we just have to remember to multiply each term on both sides by the LCD because of this distributing idea. So now let me get rid of the green, and I'll show you how I normally will write this. So I'm going to multiply all the terms by 3. So notice our 3's will cancel. We get x minus 12 equals 15. And so in one step, the fraction's gone. And this is a simple one-step equation. We'll add 12 to both sides, and we get 27. All right. So now let's do some more examples. All right, on number 3 here, my LCD is 5. So let's multiply each of our terms by 5. So notice here the 5's are going to cancel. We're left with 2x. Same thing happens here. My 5's cancel. We're left with a minus 6. And on the other side, we get 20. Remember, all the terms on each side are multiplied by 5. Don't forget the 4. Sometimes people will just want to multiply the fractions by the LCD. We need to make sure we multiply all the terms by the LCD. So now we're left with the two-step equation. Let's add 6 to both sides. And if we divide by 13, we get x equals, if we divide by 2 to get x by itself, we get x equals 13. All right, on number 4, we've got denominators of 2 and 3. So our LCD is going to be 6. Now keep in mind, to find LCD, all you have to do is write out the multiples of each number. So these are the multiples of 2. These are the multiples of 3. And you can see, oops, I skipped my 6. Hold on a second here. You can see here that the 6 is the least common multiple of 2 and 3. The way I like to do it is, let's just, let me erase all these. We can actually start with the bigger number, which is 3, and look at its multiples. until we find one that's divisible by the other number. So 3 is certainly not divisible by 2. So the next multiple is 6, which is divisible by 2. There's your LCD. So we're going to multiply all our terms by 6. And we're going to get 3 times x there, minus 54. We can cancel there. We're left with 2x. And now we need to get x on one side only. So let's get rid of the 3x term. We don't really want to get rid of the 2x term. Anytime we have a single term on one side, I usually stay away from that one. So we're going to get negative 54 is equal to a minus x. And this is just a negative 1x. We'll divide each side by negative 1, which basically changes our signs. We get x is equal to 54. All right, we got another couple to do here. So notice in this problem you have 2, 3, and 12 as denominators. And so our biggest number is 12. And in fact, 12 is divisible by 2 and 3. So there's your LCD. So we'll multiply everything by 12. So 12 divided by 2 is 6. We're going to have 6 times 3 times x, which is 18x. And the 12 divided by 3 is 4. We're left with a minus 4. Our 12s cancel on the other side. We're left with just the 5. And then we have a two-step equation. We're going to add 4 to both sides. And then be careful here. It's not 2. You need to divide by 18 to get x by itself. And so you're going to get a half. On number 6, again, if you look at the bigger number, which is 12, it's divisible by 4. So that is going to be my LCD. So let's multiply all our terms by 12. So 12 divided 4 is 3. 3 times the 3 times x is 9x minus 2 times 12, which is 24. And then we have 12 times 7 over 12. The 12s will cancel. We're left with 7x. And then plus 36. So basically, think back to what we did with CSI. We've cleared fractions. We didn't have any simplifying to do on either side. We don't have any like terms. And so we're at the isolate step. And so I need to get x by itself on one side. So let's just go ahead and subtract 7x on both sides. We're going to be left with 2x minus 24 equals 36, which is a two-step equation. And so we know we want to add 24 next, and then we can see that x is 30, or just divide each side by 2, you get 30. All right, let's do one more. Now, you can always stop my videos and try the problems on your own once you feel like you've got it. Certainly on number 7, I'd like you to consider seeing if you can do that on your own first, and then we can look at it. All right, so here my LCD is going to be 12 once again. And let's multiply all our terms by 12. 12 over 4 is 3. We're going to end up with 9x there, minus 12x. And 12 over 3, that's going to be 4 times x, minus 5 over 12 times 12. The 12s cancel, so we get minus 5. So again, if we're doing CSI, we have cleared the fractions. Now look on the left side, notice it's not simplified. So we do have some simplifying to do here. A 9x and a minus 12x is going to be a minus 3x. So we've simplified everything we can. On the right side, those are not like terms, so that's complete, at least simplified. And so now again we have that issue with x on both sides. We want to isolate x on one side only. So let's get rid of the 4x. So we're going to get negative 7x equals negative 5. So finally we've gone through CSI. Notice we have a one-step equation. To get x by itself, we're going to have to divide by negative 7. And so we're going to get 5/7. And that's it for this video.